When we talked about the mouse, I mentioned how important it was that you keep your mouse routines very short. And by short, I don't just mean a small number of lines, but they should execute very quickly. At the time, I promised I would later explain why that's the case, and that's what we'll do in this video. My intention here is for you to not only see why it's important to write those routines quickly, but to understand a little bit more about how processing handles the mouse, so that if things begin to go a little bit screwy in your program, you'll understand why and you'll know how to fix it. First, a quick recap. Here are the 5 essential mouse routines at the top of the screen. On the left, we have mouse moved and mouse dragged. Every time the mouse moves, one of these 2 routines is called. If none of the buttons are down, it's mouse moved. If any of the buttons are down, it's mouse dragged. Inside those routines, you can access the global variables mouse x and mouse y to find where the mouse was at the moment that those routines were called. In the middle, we have mouse pressed and mouse released. Those are the routines that get called when a button is pressed or comes up. And the global variable mouse button holds one of 3 special values, left, center, or right, indicating which button just went down or just came up. On the right, we have the oddball routine mouse clicked, and that is called when a button is led up if the mouse has not moved since the button was pressed. Let's now look at what happens in a typical program as it runs and these routines get called. On this slide, I'm going to watch the evolution of a program over time. Time flows from left to right. To mark off time, these 3 little boxes indicate the start of a second. So these 3 boxes are each 1 second apart. As the program runs, processing is always calling draw over and over and over again. So these boxes represent draw. The width of the box is how long draw runs for. Now in this example, just so we can see things nicely, I'm only calling draw 4 times a second. So each one of these vertical boxes means draw has been called. It runs for a very short period of time and then it stops. Then other things happen on your computer. It runs your MP3 player, it checks your email. And in this example, a quarter of a second later, draw gets called again. It runs very briefly and then it's done with its job. The computer does every other things, and every quarter of a second, draw gets called again. You'll notice that the times when draw gets called are not exactly aligned with the seconds. The computer doesn't really try to match the time that draw gets called with the second. It just tries to make sure you get the right number of calls to draw in every 1 second interval. Again, in reality, you would get 60 calls to draw in every second. I'm drawing 4 just so we can see it more easily. So let's drop down some vertical lines to mark off the seconds. So these vertical lines are 1 second apart, and now we can easily see that draw is getting called 4 times every second. Now suppose that our program is running and at some point we move the mouse. So the processing will automatically call mouse moved. So this yellow bar gets called and you can see I've made it very short so it runs for just a tiny little moment and it's done. Now suppose I move the mouse a little bit more. Well, every time the mouse moves, mouse moved gets called. And so here I've moved it 3 pixels one way or the other. Mouse moved got called 3 times and draw is still getting called on its regular schedule. Suppose now I push down one of the mouse buttons. So processing will call mouse pressed. Suppose I do it a little bit after I just did all of those moves. So there's mouse pressed, it gets called. Again, we're reading everything left to right, so it gets called, it runs very quickly, it's finished. Now the button is down and I move the mouse. So mouse moved doesn't get called, but mouse dragged gets called. So I move the mouse around and mouse dragged gets called a whole bunch of times, and then I let go of the button and mouse released gets called. And here's an instance of mouse released. And so we can see reading left to right, mouse pressed got called, and then draw got its chance. Mouse dragged got called a bunch of times, then draw got called again. Then mouse released happened and draw got called again. And everything is interleaving very nicely. Draw is doing its job every quarter of a second. Well, we can go ahead and do this again. I'll press the mouse again a little bit later, drag the mouse, it gets called a bunch of times. I let go, and mouse release gets called again. And just for fun, let's say that at some point we click the mouse, and so mouse clicked gets called. But remember, mouse clicked gets called when the button comes up, when the mouse hasn't been moved. So if mouse clicked got called, then just before it, mouse released got called, and just before that, mouse pressed was probably called. So those three little bars indicate the button going down and then being released, and because the mouse didn't move, mouse clicked at the very bottom got called. The important thing to realize about this whole diagram is that everything is taking its turn. Everything is happening in a very interleaved way. First this, then the other, one after the other. Suppose that one of these many, many little programs took a long time. For example, suppose that one of the instances of draw, rather than taking just a tiny fraction of a second, took 5 seconds. So suppose we're in the middle of draw and it's drawing some very complicated thing and it's taking a long time. We click the mouse and drag it. Processing says, oh, I want to call mouse pressed and I want to call mouse dragged a bunch of times. But I can't do it right now because draw is running and it can only do one thing at a time. So what does it do? It builds a queue. The queue is just like the queue that you might have at a turnstile trying to get into a subway. Everyone lines up and you take your turn. And the person who's at the head of the queue goes through. Then the second person, then the third person, the fourth person, and so forth, one after the other. Well, processing does the very same thing. If we're in this little program that's running and draw happens to be taking a long time, and you click the mouse, well, mouse pressed goes onto the queue and it waits its turn. And when draw is finished, mouse pressed gets its chance. Let's take a look at what this might mean. Take a look at the second row, the row for mouse moved. And take a look at the second block where I've moved the mouse a bit and mouse moved got called 3 times. Suppose for some reason the third call took a long time, here almost 1/5 of a second. Well, that's going to be a problem. Take a look directly above that block and you'll see that draw wants to get called, but processing can only do one thing at a time. That particular instance of mouse moved is already running. So that instance of draw gets put on the queue and it waits until mouse move has finished and then it gets a chance to execute. So now this is what our timeline looks like. Take a look at the top row, the row for draw, and you'll see that the frames are no longer coming out in equally spaced order. We get our first frame, our second frame a quarter of a second later, and then there's a long gap before we hit the third frame. Then the fourth frame comes pretty fast, and then they start coming back in at regular intervals. Well, in this example, that's not so terrible. A little delay here and there, you'll probably never notice it. And really, if this was all happening 60 frames a second instead of a quarter of a frame a second, a little bit of a delay here and there, not something you would notice. So let's crank it up a little bit. Let's say that for whatever reason, when I wrote mouse moved, when you move into a certain place, or maybe you move the mouse on top of a certain object, I want to have a whole bunch of things happen and I write a lot of code and it takes a long time. Now it's taking almost a second. What happens? Everything that wants to happen gets put on the queue. Everything gets delayed. We end up missing a bunch of frames. Mouse drag gets delayed. Mouse pressed gets delayed. Our program is suddenly becoming unresponsive. I click the mouse and nothing happens for a while. And then suddenly, bam, the mouse moves. Or the object I clicked on changes color, whatever happens. Because mouse moved took so long to run, it both messed up our visuals because now we've missed a bunch of frames and the picture looks like it's frozen for a moment. And we've also messed up our interactivity because we're clicking and we're moving and nothing is happening. This can happen from any of these routines. Suppose that mouse pressed, for some reason when we write it, it takes a long time to execute. Once again, as long as mouse pressed is executing, everything else gets put on the queue. It gets pushed off for some future event. And now everything is getting pushed away so far that our program is just becoming sluggish.
To see this sluggishness in action, in part 2, I'll demonstrate these issues on a running program in real time.